Construction work is one of the most difficult and safe professions to work in. According to the Global Work Organization, GWO, 108,000 construction workers die every year while performing their job, and this cipher represents approximately 28% of the accidents in every single job worldwide. In Mexico alone, an accident occurs every 75 seconds, and each 8 hours a builder dies. This is believed to be the product of loose safety regulations and a lack of control over the ways many big construction companies enforce them in their work sites. During this project, we decided that we wanted to put our little grain of salt to try and make this job for these workers a little bit easier by making their measurement techniques safer than they have ever been before. That's why we present to you MeasureMax, Safety and Practicality. MeasureMax is an ultrasonic distance sensor programmed to read and record distances with ease, making the once tedious and dangerous process of measuring manually in constructions a thing of the past.
Our prototype is pretty simple. It is based on a temperature pistol when it comes to the design. The first part would be the LED display. It will display the distance that is measured by the ultrasonic distance sensor. For example, here it's measuring 120 centimeters. Then come our two LEDs, the red LED and the LED RGB. The red LED will tell when the reading is high, which means that the pistol is on. It will light up once you push the trigger or button that is located under the top part of the pistol. Then the LED RGB is different because this one will change color depending on the distance that is measured by the UDS. In this case, for example, we have blue, which means that it's 120 centimeters away from the target. This one will be useful when wanting to divide areas in a construction site. That's the way you can color code them, and it will be easier for workers to work with. Next up is the ultrasonic distance sensor, the key part in our pistol. This one will measure the distance between the mouth of the pistol and any object it is pointed towards, which means that, let's say you have a wall exactly 60 centimeters in front of you, then the ultrasonic distance sensor will be in charge of measuring that distance and then sending it to the LED display so that you can know that same distance. Then you have the trigger and the push button. And even though it might seem simple, it's actually a big part of the pistol as well. This one will mark when the pistol is on or off, turning the reading from low, off, to high, which is on. Finally, we have two other important parts. The battery compartment, that is the place where one puts the batteries in order for the pistol to keep running, and the Arduino and breadboard location. Of course, we couldn't do any of this without our main circuits, and this one are located right between the battery chamber, the sensor, and the LED. This is for better efficiency.
This is our circuit and code. It is completely functional. What we do here is that we have the ultrasonic sensor, which is going to be our method of measuring distance in the product. The RGB LED is going to be something that determines an estimate of the distance. It is not completely accurate. It is just it just tells you between which distances the thing could be, and the LCD the LCD displayer is actually going to put out the exact distance between the product and the object we are measuring to. And well, this is just a button to represent the trigger and that it is turned on and functioning. So let me just demonstrate it. And now the circuit is functioning. Turn on the product. Here it is. Now go to the LED, the sensor, and well, you can adjust the measurement to whatever distance you might want to measure. Let's say here, the distance is between 150 and 120 and 180 centimeters. So the LED is blue, as we can see here. And here's the exact measurement, 162 centimeters.